Good evening, class.
Good evening.
How are you?
We are fine.
Thank you so much. We are going to study as usual. Remember, we are upon unity number 8, which is called the projectile motion and circular motion. We are going to study as usual physics. We are on unity 8. Unit 8 called the projectile motion and the circular motion. So, I would like you to remind me what you saw last time. Mr. Basiru?
We have seen that the definition of projectile, where projectile is anything thrown in space.
Thank you so much. Flower, give him flowers.
Flowers.
Another one. Genius.
Thank you. We have seen the maximum height of flight.
Maximum height of flight.
We have seen the definition in terms of projectile motions, which include the maximum weight, range, time of flight as definition as usual.
Clap for him. So I'm going to show you a picture, then you will tell me what you have observed. Without delay. You have to observe this picture. What you are seeing there? The zero.
We are seeing a ball.
We are seeing a ball. Melanie?
Also, I think the graph taken by that ball.
There is a graph taken of that ball. What can you see from this image? Pass.
I'm asking the same why that ball is moving in that direction.
He's asking why this ball is moving with that direction. So, let me give you this question. Who can read for this question?
Me, teacher.
Pass it again.
So the title of the question is question from image. Class, look at this ball as it climbs into the air at the very highest point of its flight. Just before it stops rising and it starts falling back down to my hands. What is its vertical velocity for that thin sprite second?
Repeat again.
Class, look at this ball as it climbs into the air at the very highest point of its flight, just before it stops rising and starts falling back down into my hands. What is its vertical velocity for that thin split seconds?
Yes, you are given 1 minute to discuss on this question, and then I need your feedback. Let's take 1 minute, then we go back.
May you switch on your computer?
Thank you so much. The question. Yes, you are asking to look at this ball. It climbs into air. As you see this ball, at the very highest point of flight, just before it stops rising and starting falling into my hand. What is the vertical velocity of tiny split second? I see.
So according to the what we have discussed in our peer, have you seen when our ball reaching at its highest point of flight, the vertical velocity will become 0.
Clap for him. So as he said, when this ball reaches to the highest point, its velocity, which is equal to V1, is equal to 0. So who can guess what we are going to study? Yeah, before I move on, according to your question of asking, our key question is, why is it go up? This is our key questions. So, I'm going to introduce my new section. We are going to study Haiti Max. As we have said, Haiti Max is the highest point of projectile, is the highest point of the projectile. So let us consider this motion of the projectile. So we have a projectile that is moving. We know that last time we see how we call this point. This point is called the Haiti Max. This projectile, in order to reach to the highest max, it will require time. Yeah, it will require the time. This time we call TT, and which is T max. So we are going to see the formula we use in calculating the Haiti maximum. So let me show you our instruction. So our instruction is, by the end of this unit, runners should be able to state the vertical condition at the peak, Vy which is equal to 0, and apply the maximum height formula to solve the peak numerical problem accuracy. We want to delay, let us move on. You know that from our graph, in order to have the height max, let us y, which is equal to y max, we will get a maximum height if, and only if the vy, which is equal to 0. According to the equation of full motion, equation of full motion, we know that our y is equal to Vy plus Vyt plus 1/2 Ayt. We have seen that Vy is equal to 0. Vy is equal to 0. So we will remain with y, which is equal to, we know that our gravity, when increasing in height, our gravity will take a negative. We remain with 0 minus g over 2 t squared. So we have seen that the time to reach to the height max is equal to velocity. The short velocity with remember, in order to project we need the certain angle of our projection. So our time max will be equal to Vo sin alpha over g. So you have to bracket in our function. So our y will be equal to g minus g t Vo sin alpha, which is square over g. So our final will be equal to negative, this will be subtracted to this. We remain with Vo square sin square alpha over g. So remember, this negative shows where always height is opposite to gravity. So,
Question.
Question?
How do you explain negative?
Yes, I have assumed that this negative of our height max, we know that our height is always opposite to the to the gravity. That is why we take a negative. So this will be equal to y is equal to VO sine square alpha over g. So we have already demonstrated how to calculate height max. So I'm going to give you what the example, don't resolve it in 2 minutes. So who can read our question? Mr. Emmy?
During a school sports match at Gismega Magaza, a student kicks a football from the ground with an initial velocity of 15 meters per second at an angle of 30 degrees to the horizontal plane. Take a gravity equal 10 meters per second square. Calculate the maximum height reached by the football.
So, as you are working in pair, you are going to give the answers of that question. Mr. Emmy, can you come and answer the question? So all of you let us go again. Please.
Given that we have theta which is equal to 30 degrees, then we have gravity which is equal to 10 meters per second squared.
Yes.
Then we have velocity which is equal to 15 meters per second. This question, we have seen that question is maximum h. Then as formula, maximum h equal v0 square sine square theta over 2 times gravity. Then replace v0 square equal to 15 square sine square 30 divided by 2 times 10. Then we have 15 square times square divided by equal to 0.81 meter as maximum h.
All of you give him flowers. Flowers. So thank you, Amy. We have calculated our height maxi by using this question. So we have to conclude that I've seen different things in our lesson. I've seen height maxi is the point of the project to reach to the maximum. Also, have seen that maximum height and projected vertical becomes maximum when our velocity on vertical axis is equal to 0. So Rainbow then give you a homework. Before sharing this homework, do you have a question?
No question.
So if there is no so far question, we will submit this homework tomorrow. Thank you so much. Thank you for your active participation. We shall meet next time. Thank you.
Thank you.
Thank you.